Okay, so when you look at this problem here, so absolute value -3, you probably know the answer is 3, right? You've seen absolute value before. Absolute absolute value makes whatever the sum is inside of there positive. Whatever's inside of there, the total would be positive. So it's the distance from the number. So solve this one. In fact, I have a guess that you could probably solve this one. What value would make this equal to 5? So x could be 5. And you probably know x could also be -5. So oftentimes there's two answers. So the way we solve this one, this type of problem, is actually to do, we split it up into two cases. So it's kind of like the positive case and the negative case. So the positive case would be, instead of absolute value, I'm just going to put x, put it in parentheses if you wanted, x equals 5. In the negative case, I'm going to do that again, but instead I'm going to use parentheses here. You have a choice at this point. You could either put the negative over here with the 5. The book recommends you do that. I tend to put the negative here on the left-hand side. With that whole side, make one side negative is how you handle the negative case. So if you make the left-hand side negative here, you'd have to do an extra move. So I divide by -1, divide by -1, I get x equals -5. So I get two answers. No surprise there. With absolute value, typically, not all the time, but many times, you're going to get two answers when you have an absolute value equation. So let's try a little tougher one. We're going to progressively get a little bit more complicated. So this next one, you're going to have plus or minus. So the positive case is easy. 2x minus 1 equals 5. You'll solve that one. I guess you get 2x equals 6. Divide by 2, divide by 2. Sorry, that's really sloppy. And you get x equals 3. And you can always double check it. Not a bad idea to check it in. 2 times 3 minus 1 is 5. That works. Another one, we're going to make that absolute value bars parentheses. And then we have to make one side negative. Again, the book will probably tell you to put on that side. That's fine if you want to do that. I have no problem with that. I tend to, for reasons I'll explain in a few minutes, I tend to put the negative on this side. So either way, once you have your negative there, so this would be -2x plus 1 equals 5. You're going to subtract 1, get -2x equals 4. Divide by -2, divide by -2, get x equals -2. And if you want to double check that, 2 times -2 is -4, minus 1 is -5. Absolute value -5 is 5. That answer works, and that answer works. Never a bad idea to check your answer, especially in this section, I would say. I would say for sure this is a great section to check. Let's check another, let's do another one here. So just to see if we're getting it. Positive, negative case, 3x plus 2 equals 11. Sorry, that's -3x plus 2 equals 11. And then over here, you'd have -3x plus 2 equals 11. And again, you make one side negative. I'm going to make that side negative. And that just means change side. I said negative, but actually like this -3x will become a positive 3x. And then the -2 equals 11. Solve that. I'm going to go a little quicker. So that'd be 3x equals 13. And then divide by 3, you get x equals 13 over 3. And this one, if you subtract 2, you get -3x equals -1. I'm sorry, that's 11. So that would be actually 9. Sorry. Divide by -3, you get x equals -3. And again, you can check both these answers by plugging them in and see if they work. When you do, they do work. Okay, so now we get a little tougher. Isolate the absolute value. So when I say isolate, that means to get the absolute value, which is this guy right here, all alone. I want to get that absolute value bar x plus 2, absolute value of x plus 2 all alone. The -1 has to go, the 3 has to go. I would move the -1 first. It makes more sense here. So you get 3 times absolute value of x plus 2 equals 9. Divide by 3. You get absolute value of x plus 2 equals 3. And now we're ready to split up that equation, right? So we have it ready, plus and minus. The positive case is x plus 2 equals 3, so x equals 1. The negative case, again, you have a choice. You either put the negative with a 3 or negative there. I prefer to put it at the beginning. So if you do it that way, you get negative x minus 2 equals 3, negative x equals 5, x equals negative 5. And again, check your answers just to make sure it works. So plugging it back into the original problem, does 1 work? Let's see. 3 times 3 minus 1 is 8. That works. Negative 5. That's absolute value of 3, which is 3. 3 times 8 is 9, minus 1 is 8. They both work. So that's really good. You're happy with that. And the reason we check is sometimes, like this problem, you might get what are called extraneous solutions. So this definitely could happen to you. So this is isolated. So we're going to take the positive negative case here. But something really weird is going to happen when we do this one. So 3x plus 2 equals 4x plus 5. And over here, we're going to have 3x plus 2 equals 4x plus 5. I'm going to make the whole left-hand side negative. And then I'm going to solve both these. And I'm not sure if they're both going to work here. So here I get x equals negative 3. Whoops, negative 3. Can't show them at work, I guess. I get negative 3x minus 2 equals 4x plus 5. So if I get 7x equals negative 7, okay, divide by 7, x equals negative 1. So I think I did both those right, but it doesn't mean they're both going to work. So if I plug in negative 3, I get, for x there, I get negative 9 plus 2 is negative 7. Here I get negative 12 plus 5 is negative 7. That seems to work. Okay, well, maybe this works. I get negative, wait. Let's plug this in again. Let's make sure. So this would be 3 times negative 3 is negative 9 plus 2. Negative 9 plus 2 is negative 7. The absolute value of negative 7, here we plug in negative 3. You get negative 12 plus 5 is negative 7. Uh-oh. Absolute value of negative 7, 7. 7 equals negative 7. That's not true. This is not a real answer. We didn't make a mistake to get it, but anytime x is inside of absolute value bar, you have the potential for what are called extraneous solutions. And so that answer doesn't work. Let's check this one and see if this one works. So we get negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. Over here, negative 4 plus 5 is 1. 1 equals 1. That does work. So one of the answers works, and one of the answers doesn't work for this one. Now let's look at inequalities. So this is a little bit tougher, a little bit different. So let's look at these for a minute. Okay, so now we're combining two ideas here. We're doing inequalities, which we studied the other day, and absolute value, which we studied today. So we're kind of combining these two ideas. So one way to think about this, like what values could you plug into this expression that would make it true? Like 2 would work, 1, 0. I think even negative 1 would work. Negative 2 would work. I don't think negative 3 would work. Negative 4 would not work. Negative 5. 4, 5, 6, positive would not work. There's only a few numbers kind of between, I'm not sure. I'm just guessing between 3 and negative 3, somewhere in there, but not including either one. But let's actually solve it the same way we've basically solved our other problems. So let's try this. So we're going to take the positive and negative case. The positive case would be x less than 3. Okay. The negative case is you have a choice here. You make either the left-hand side or the right-hand side negative. If you do the way the book says it and you make the right side negative, you'll have to remember to magically switch the sign. I prefer to make this side negative so I don't have to remember any extra rules. I already know the normal rules. I'm just going to go by that. So solving these, I already got that one. So if you divide by negative 1, I remember that when you divide by negative, you do have to switch the sign. So this would be now greater than, and I guess that would be negative 3. Okay, so if I draw this graph, and I've got negative 3, and I've got 3. We do the different colors here. So this one is going to be x less than 3 looks like this, pretty much. This one is x greater than 3. That's an open circle, I guess. Really bad open circle. That's open circle. Okay, so I have to figure out if this is an and or an or statement. So this is kind of a silly memory trick, but do you see the sign right here? So we say that sign less than, right? Less than. So I'm going to try to spell it. Maybe I won't spell it right. I'm not sure. Less than, less than, less than, less than, less than. So when you see a less than sign, I want you to be thinking of and. So this is actually, these two are connected with an and statement here. So this is an and statement. So the and is the overlap, which is like from here to here and everything in between. So that's my final answer on the graph. If I wanted to write it out, it would be something like -3 to 3 parentheses, parentheses in interval notation. I'll show you the shortcut in a second. Let's go to the or statements here. So on this one, we're going to solve it. So first we have to isolate the absolute value. So I have to get the 5 to the other side. I'm going to add 5 to both sides. So I have absolute value of x plus 1 over 2 is greater than or equal to 4. Okay, so for this one, let me just kind of move these out of the way here. Okay, so I'm going to solve this by splitting it up. Get a positive and a negative case. Positive case, x plus 1 over 2 greater than or equal to 4. Negative case, x plus 1 over 2 greater than or equal to 4. And I'm going to make a negative sign there. Okay, so we're going to multiply both sides by 2, I guess, to get rid of the denominator. And we get x plus 1 greater than or equal to 8, times sign there. Subtract 1, you get x greater than or equal to 7, I guess. Because that canceled there, right? Okay, so that's half my answer. But again, this is, let's see, what's the sign here? So this is, I think we call that the greater symbol. So great, I'm going to try to spell that. Greater symbol. So less than, greater. So when you see a greater symbol with the absolute value inequalities, there's going to be an or in between these two. Let's keep going. So we get, let's see, this would be negative x minus 1 over 2 greater than or equal to 4. I'm going to multiply both sides by 2. Simplify that just a little bit here. So that cancels really nicely. I get negative x minus 1 greater than or equal to 8. Add 1, negative x greater than or equal to 9. Divide by negative, that's negative 9 now, and switch the direction of the sign. So I've got these two things. So I've got negative 9 and 7. Graph this one in red. So that would be closed circle, arrow to the right. Graph this one in blue. It's going to be a closed circle, arrow to the left. And this is an or statement, right? So or is either one of those true. In fact, if this is and, there would be no solution. There's no overlap. But anything in the red is a solution. Anything in the blue is a solution, but nothing in between there. So the final answer would be closed circle there, arrow to the left, and closed circle there, arrow to the right. I think that's about it for the lesson. So enjoy your weekend.